okay, I want to be able to solve for EC, okay, in this triangle here on the right. Okay, EC, that's the side like I'm looking for. Okay, now here's a sticky point with this question. It's not necessarily clear. Okay, 91.7 degrees is the angle from here to here. Okay, I don't know this angle and I don't know this angle. Okay, so my job here, okay, if I were to find this from the beginning, I could then do, well, I'll show you, but then I can do a second step to figure this one out, and then I can just use a trig ratio to find this. Okay, those are my 3 steps. So this is going to have 3 steps, this question. Okay, so first things first, in triangle ABC, find angle C. Okay, that's what I want to find. Okay, so let's take a look here. So if I were to use, I'm standing here, I can use opposite and adjacent. So that sounds like tangent. Okay, so I can use the tan of theta is equal to 21.3 divided by 19.4. Okay, I don't normally do this. I don't know why I've started doing this, but I normally use the lowercase t for tan. Okay, then I can go to my calculator, get a ratio or a decimal number for this. If we go 21.3 divided by 19.4. Okay, so tan of theta is 1.09, we'll call it 98. Okay, and then you can go the tan inverse of 1.098 is equal to theta. And then so theta, or angle C, is going to equal the second function, or the shift tangent of this number, right? So if I click this, I should get 47, call it 47.7. Okay, now that's nice because here's a rule now. Okay, I'm going to show you something. Get rid of some stuff here. You can see. Okay, step 2 here, I'm going to show you. Okay, if you had a protractor, move this down here for the explanation. If I had a protractor like this, you would say that there's 180 degrees from one side to the other. Okay. Now, what you have here is I've now figured out, if I zoom in here for a sec, I've now figured out that this angle here was 47.7 degrees. Okay. So I know from one side to the other, okay, from here to here is going to be 180 degrees. Okay. Now, my result, what I'm after now is this angle here. Okay. And if I can figure it out from the information provided, well, it turns out that I know everything from, I know this is 91.7 degrees, and I know that this is now 47. Right? So if I add those two together, the green and red, and I subtract it from 180, so if I do 180, if I do the black section, 180 degrees minus the red section minus the green section, that's going to equal my angle down here. Okay, so let's go back. We'll actually go do the work now. This is my second step. Second step now is to solve for this. So I can do 180. We'll call this, what angle do we want to call this? We'll just do it, okay? 180, I don't really know what to call it. So I'm going to go 180 minus the red section, which was 91.7, minus 47.7. That's going to equal this black section here, okay? This red angle that I'll color in now, okay? So you're going to get 180 minus 91.7 minus 47.7. It's 40.6. Okay, and we're almost there. Degrees. Okay. Okay, now remember the goal of this question was to get this. So I now have the angle in the corner, I have the opposite, and I want to find the hypotenuse, right? So what you can do, step 3 here, we'll do it in purple. Step 3 will be use SOHCAHTOA to find EC. Okay, and so you can go, so I'm going to use sine law, right, because I have the opposite and the angle. So I can go sine of 40.6 is equal to, the opposite in this question is 23.5 divided by the hypotenuse. Okay, and you can do the math on this if you'd like. You go 40.6 and hit, we don't want the inverse on, we'll hit sine of that angle, be 0.65 is equal to 23.5 over the hypotenuse. Okay, and then the goal of this is to get the hypotenuse by itself, because the hypotenuse is EC. Okay, so I want to get this by itself, right? The hypotenuse, because if I get it by itself, I can solve for it. Okay, and so if you're just going to do a little simple math manipulation here. So if I multiplied both sides by hypotenuse, then they would cancel here, and I'd be left with the hypotenuse 0.65 is equal to that. Then what you could do is divide both sides by 0.65, right? And then they would cancel here. So your answer, sorry, I'll just do this because it's messy. I'm trying to save space, but I'll actually do it. So what you're going to have here is hypotenuse multiplied by 0.65, which is equal to 23.5, right? And then you can divide both sides by 0.65. They cancel, and so you're left with the hypotenuse is equal to the division of 23.5 divided by 0.65, right? Okay, I'll draw this, let me take this up here. So hypotenuse is equal to 23.5 divided by 0.65. Right? And the hypotenuse is equal to the answer here. 23.5 divided by 0.65 is 36.1. Okay, we can call that centimeters. Okay, that's side length EC. Okay, now sometimes in the real world, why I'm showing you compound angles is sometimes you need to solve information or like find information over here on the right of, let's say, somewhere in the real world, but on the left side of the picture there's information on the in the real world that I can actually use. Okay, and so if I could create a diagram from the real situation, right, then I can use the information from the real world example or the measured data to answer something about that particular location, even though I don't necessarily have information. Okay, and so you can create your own compound triangles or compound shapes in the real world and use the information or measured data from the real world to answer questions about anything that you ask yourself a question about. Okay, so that's kind of the idea with this. Okay, is can I take information from given information and answer something else? Okay, so that's it for this. I will do the last part of this question, the actual word problem, in a third video. Okay.